Hello, good morning to all. My name is Glenn. We are actually the group for EKC 483. We have given the title for Selective Catalytic Oxidation of H2S to elemental sulfur in the presence of ammonia. Where a brief introduction whereby you can see the selective oxidation is actually cell gas treatment. It changes the H2S to ACS, which is the ammonium thiosulfate and also sulfur. This is a new vapor phase catalytic process. You can see the importance is for the energy shortage because it's considered non-renewable, thus you need to extract in high efficiency. It's also considered as a toxic and has poisoning effect on the metal catalyst and also corrosive to the piping. So next you can see that this is actually the table whereby it's put in ppm and also the effect on human, which is considered as hazard, and it's a safety measure actually to measure the amount. So our government and also OSHA, which is Occupational Safety and Hazard, has put up these regulations to follow. And for the current technology to remove H2S, you can see that actually we use clouds, which has two steps inside. Is the thermal oxidation and catalytic, but it doesn't remove everything. Thus we need the tail gas treatment, which is actually MODOC and superclouds. It is actually based on these four reactions, where we're going to discuss the parameters further on to differentiate which one is better, which condition is better. Thank you.
First of all, we will investigate the effects of water vapor in selective oxidation with H2S. Generally, the presence of water will lower the conversion of H2S. And for instance, the vanadium titanium supported on titanium oxide aerogel catalyst was studied, and it was shown that the conversion of hydrogen sulfate was lower in the presence of water. In order to investigate the reason behind, we need to understand the elementary reaction occurring in the Claus process. As you can see from the slide, the presence of water actually inhibits these two forward reactions. However, the presence of water can promote the reversible reaction of this one. And the total effect will be the drop of hydrogen sulfate concentration conversion. The next factor to be considered is the effect of component loading. 5 niobium iron mixed oxide of different niobium to ferrum atomic ratio and pure alpha ferrum oxide and niobium oxide were tested. And the result is shown in the table 2, in which the highest conversion was obtained by the niobium to ferrum atomic ratio of 1 to 2. And all the niobium ferrum catalysts have higher selectivity of ACS than sulfur, and they all show a very low selectivity of sulfur dioxide. The high catalytic performance of 1 to 2 ratio of niobium ferrum is related to its physical property. The catalytic result shown that the 1 to 2 ratio of niobium ferrum mixed oxide catalyst has the highest batch area and the pore volume, and both these characteristics will bring to the high catalytic performance of ferrum niobium mixed oxide, and as a result they will have the highest conversion compared to others. Thank you.
So now I'm going to talk a little bit about the effect of ammonium vapor. So the presence of ammonium plays a very important role for H2 conversion. Here is a two reaction which to remove SO2 and ammonium thiosulfate. So under the same condition of concentration H2S, H2O and O2 operating temperature GHSD, which is kind of contact time, the increase of ammonium will increase the selectivity of elemental sulfur and H2S conversion. These two reactions show very clearly how the selectivity of elemental sulfur and H2S positive effect of catalytic performance. So now I'm going to talk a little bit about the next factor, which is reaction temperature. The change of reaction temperature can greatly influence the catalytic performance. Optimum H2 conversion can be obtained in a reaction temperature of 260 Celsius. Further increasing the reaction temperature will lower the performance of the catalytic. So the possible reason is that the equilibrium of cloud-bound process is decreased with the increasing of reaction temperature. So if the reaction temperature lower than 220, the H2S conversion is decreased relatively. This is because the condensation of sulfur occurs at the surface of catalyst. So here is the reaction temperature can affect the selectivity of O2. This reaction shows how the selectivity of O2 is affected. So overall, the increase of reaction temperature from 260 can increase the SDS fraction, but it decreases the H2S conversion.
Hello everyone. So the next effect is the effect of catalyst preparation method. So three different preparation methods have been studied. The first one is conventional, second one is integrated, as well as the non-hydrolytic soil preparation method. So we know that the third one is has better H2S conversion, because one of the reasons it can be used to solve the fast reaction rate of soil gel method. Okay? Another one is that it has higher surface area and total pore volume than others. So another catalyst has been used with the same preparation method. So we know that the preparation method using the non-hydrolytic soil gel method has higher conversion of H2S. Okay? The next effect is the effect of partial pressure of oxygen. As we can see here, the study we using the catalyst of CO3O4 and we varying the ratio of oxygen H2S from 0.5 to 4. So the increasing of the ratio of the oxygen inside the reaction, we increase the selectivity of SO2, also the conversion of H2S. We also increase the selectivity of ammonium thiosulfide, but we decrease the selectivity of elemental sulfur. So the effect of GHLD, which is the gas velocity. So the increase of GHLD meaning that we lower the contact time for the process. Okay? Using the catalyst vanadium and SiO2, we know that the higher GHLD also show that the increasing of the conversion of H2S as well as decrease the selectivity of sulfur. Okay? So the next effect is the effect of reaction time. So two types of catalyst has been tested at 260 degrees Celsius. So we know that the first 30 minutes, the bulky vanadium show that 100% of conversion of H2S. But after an hour, the conversion increased for both catalysts. Okay, thank you.
Now we will look to the effect of the catalyst support. Example of the catalyst is VCI-PILC. By using this catalyst, we can get 98% of H2S conversion. The performance of the catalyst depends on the distribution of the vanadium species on the support. The structural properties depends on the nature of the pillar, preparation method of catalyst, and calcination temperature. The surface area will determine the performance of the supporter in the catalyst. Higher surface area is a good. At the beginning, silica vanadium hydroxide have higher conversion of H2S, but it's only for the first half an hour of the experiment. Actually, titanium vanadium hydroxide is more stable catalytic catalyst and show a better conversion of H2S for the whole of the experiment. The factor which makes this catalyst is better is because it was a good redox property and has a lower decreasing of the surface area. And this also can play a positive role in activity and stability of the catalyst. The importance of the redox behavior of catalyst is there are two approach methods in order to study the oscillation state of the first method is PTO, which catalyst with N equals to 0.2 will consume of oxygen and perform well in oxidation. And the second method is SPS. From the result, the surface area of the catalyst will reduce from V5 plus to V5 plus after selective oxidation of H2S. And the composition of the catalyst activity in different speed composition. This catalyst can be used to do the reaction was conducted on this catalyst and with various composition, which is H2S, O2 and ammonia and H2O, and the difference of reactant composition will have a different formation of H2S, and this is the result from our experiment. Thank you.
So for the final one is the conclusion. You can see here we tested based on the term paper. We can see that a lot of various catalysts have been tested in term papers, and you can see the efficiency for the selective oxidation is defined by these parameters. So for the conclusion, you can see that in order to get the